Hey, Robert, can you hear me?
I can hear you loud and clear.
Okay, great, great. Can you see me?
Yep.
All right, cool. Yeah, we have problems. We had to move rooms, so. This is fun. Is your account not working? I'm usually a very, very patient person, but I'm losing my patience right now. Number 6.
Yeah.
Can't imagine why I can't remember this. It's like it's been about 3 days since we did it. Yeah, sorry about that. It happens. Let's see. Anybody else want in? All right, gang, the question, do you guys even see that? You may have any luck? You may want to move up here. I don't know.
I got my laptop on the Pearson lab, so I can easily go to any question. Should
Okay, what about the rest of you?
How about my trailer right there?
You can, if you want, you can sit right here. Whatever you need to do. I want you to be able to see it, otherwise it's kind of counterproductive.
I remember solving this one by bringing the stack crunch into a custom calculator.
Yeah, what I would do here is I would go to click copy table and open up in Stack Crunch. And of course, it's not going to let me because
It should give you the option to allow pop-ups. So
I've done that 3 times. All right, so there we are. First thing I would do is I would remember that the formula tells me to take the sum of the x's times the p of x's. So the first part, really, the mean is pretty easy to find using Stack Crunch, a lot easier than using your calculator. So really all I need to do is multiply 0 times 0.32, 1 times 0.33, and so on and so forth. I actually could go through there and just multiply them and put the numbers over there and add them up. I think it's easier if I go to data and go to compute and go to expression. So I want to build an expression. So I want what's in the first column multiplied by the second column. So I'm going to build, and I'm just going to click accidents daily, and I want to multiply that by the p of x. Now, something I've noticed in teaching this a billion times is sometimes the name of the variable throws students off because they're used to seeing x's and p of x's. And if that makes you happier, then you could go up here and just change that to x and change that to p of x, and you have it more in what I would call a convenient notation, or at least familiar notation, something you've done before. So again, same thing, dat, compute, expression, build it, and take x times p of x. All right, click OK, and hit compute. And you'll see that you'll get a bunch of x's times p of x's in the third column. So guys, we've done everything up there. We've taken the x's times the p of x's. The only thing we have left to do now is just what? What's the big sigma over there stand for? Add them up, right? Sum. So I just need to go to stat calculator. I'm sorry, stat summary stat column. And I need to come down and find, I need to click that third column and just come down and find sum. And when I do that, I get 1.46 as the mean. Now, I don't know for sure if we have the same numbers in the, let me make sure no one else is in the meeting. No. So now when I think about gosh, I'm so glad I teach online anymore. This is horrible. Does anybody see it? Okay. Well, the standard deviation, we'll look at the variance first, is just the sum of the x's minus the mean squared times the probability of x. Now this one's more advanced, right? It's tougher to do. And I'm pretty sure the next question on the assignment will be to, I don't even know if it'll allow me to check the answer. Okay. So the next thing it's going to do is it's going to want the standard deviation. So guys, again, keep that 1.46 in the back of your mind, because for this problem right here, instead of this mu, we need a 1.46 to go there. So what do you think? What are we going to do? Did you watch Kentucky play Saturday? Good.
How does that work?
We do the same thing, really, aren't we? I mean, we're just going to have different stuff that we put together. So I'm going to go in and I'm just going to build. I'm going to go to data, go to compute, go to expression. And I'm just going to build another expression. Now, you guys tell me, what am I going to do first? Well, I'm going to do a left parentheses, because that's exactly what I got there. The next place I'm going to do an X. So guys, this is where I think it's a lot more beneficial to rename the column as X and P of X. Now, if you completely know what you're doing, you got a PhD in this stuff like me, you don't really need that. But sometimes you need your problem to look like the way it's been taught to you in the same notation. And this is a situation where you're allowed to change the variable name. So next thing I need to do is the X. What's the next thing up there? A minus. Next thing is a 1.46. It was 1.46, right? Okay. Next thing I need to do is write parentheses. Next thing I need to do is square it. Next thing I need to do is multiply by what? Probability of X, yeah. It was just kind of like reading it. Just read it left to right. And make it happen. All right, but there's more to it. It seems like there always is, right? So when I click this, what I'm going to get, just like before, I'm going to get a list of numbers. So I've got everything not included in the sum, or I'm sorry, not everything that I need to sum up. I still need to sum those things up. So sum up those columns that we just created. Be sure you can see. And I get 2.4684. Type that in, it's going to be wrong. Why? Isn't that heartbreaking, really? You've done everything right, you get down this number, it's perfect, and you type it in, it's wrong. Why? Because it asks for the standard deviation, not the variance. To get the standard deviation, we have to take the square root of both sides. The square root of the variance is the standard deviation, so I have to take the square root of all that stuff over there. So guys, what I would do if it was me, because you're allowed to bring a calculator to the test, I wouldn't go through Stack Crunch for something like a standard deviation, or I'm sorry, for a square root. I'd just pick up my calculator and do the square root of 2.4684. Okay, so it wants us to go to Type in integer, so 3 places, so you said 1.571?
571.
Okay. So the 3 places?
That's very close.
You don't care how old you are, how good. Doesn't it feel good when you see excellent pop up there? Yeah. Doesn't always happen. All right. Make sure no one else is in the waiting room. Hey, Lindsay, can you hear me? Lindsay, can you hear me?
I can.
Okay. Everybody else is muted, so.
I will say though, it's a bit hard to actually see the screen. I don't know if it's due to the glare or.
Okay, well, let me see if I can fix that. That any better?
Much.
Okay, good. All right, guys, it's up to you.
Well, I had the SCV question, but I didn't put the number. This started out the data set below shows the overall miles per gallon of a new model small SUV. Compute the first quartile and third quartile in the interquartile range. I wrote
Okay,
it down so I don't.
so let's see if we can find it. So it's in the midterm study guide?
Yeah, might be like 5 or something.
It's probably like,
No, I got that one right.
is this it?
Well, I might have had a question about that. But no.
Is that it?
Yep.
All right. Guys, if I was gonna do this problem, I would, like everything else, open it up in Stack Crunch. So what do we want? We want the first and third quartiles in the IQR. So again, what I would do is go summary stat columns. Put bear 1. So it looks like I need the what, Q1, Q3, and the IQR. So 23, 21, 23, and 2. Don't you wish that my stat lab would be consistent and always want you to round the same way? Like either 2 places or 3 places, not 4 places and 1 problem. I do.
Yes.
All right. So the 5-number summary is next. Well, guys, we know 21 and 23, right? We know 2 of the 5 that we have Q1 and Q3. So what we need to do now is find the median and the lowest. Well, guys, I can look at my data, and it looks like to me that the lowest is 14. Kind of a good thing about having. And the highest is probably what, 20, 28. Now, I don't know about you, but I was a nerd. I still am. And I would want to confirm that because it would drive me nuts if I didn't. So I would go ahead and do summary stat column. And I would find the lowest, the min, and the max, just to be safe. Because I would have never forgiven myself if I glanced at those data points and missed something. So 14 and 28, so 14 and 28. So guys, next thing I need is the median. So let's do it. So summary stat column, layer 1, median. So 21. Check it. We know it's right. Now, constructive box plot. Now, guys, these are harder because you really have to pay attention to detail. And if you're anything like me, that you don't like to pay attention to detail because it takes too long, it can be annoying. But you know, you just have to slow down, and I have to force myself to slow down as well. So, guys, I'm going to go to create a graph, and I'm going to create a box plot. Layer 1. Now, what I'm going to do, I'm going to draw this horizontally. So I'm going to click that button right there because, why would I do that? Yeah, well, the reason I do it is because when I look at my answers right here, they are horizontal box plots, right? What I'm trying to do is I'm trying to find the correct box plot that matches with the choices that they're giving me there. Well, if I create vertical box plots, that could be a little confusing, right? So I'm going to go for it and hit compute. Now what are the characteristics of now I look at that, what happened? I see that they gave box plot without outliers. So I can have a box plot with outliers. Well, that's fine. All I got to do is just go back and create the box plot still horizontally, but I don't want to use fences to identify outliers because they didn't. Now, I think that's wrong. I think my stat lab screws up when they do that, but yeah, it is what it is. So now I start looking at it and I start noticing the characteristics of it. The characteristic that I notice is that well, okay, why do you choose A?
Because the other one's box is closer to the outline.
Yeah. What I see there is I see that value right there is what? The minimum value, so it would be 14. So I come to these box plots here, and you're right, it is A. So I come to this one right here, and I see that that aligns with 14. I come to this one right here, I see that aligns to like 20. That's not it. And I see this one right here aligns to something below 12, so it's irrelevant. It's below 12. So I know that in this case, A has to be the correct choice. So I'm just looking for those characteristics. It could be where something begins. All you got to do is rule out one thing, right? If one thing doesn't match up, then it can't be. Now the next thing is what's the shape of the data? The distribution is either right skewed, left skewed. How do we determine that? Well, if we look at the median of 21, it's 7 units to the left to get a 14, and it's 7 units to the right to get a 28. So what they're doing, they're comparing the smallest value to the median and the largest value to the median. But in our case, is there any difference between those two values? So what am I going to say? Symmetric. Now, if, and this, I don't know what kind of questions you guys are going to get on Wednesday, because they're all going to be scrambled. All of you are going to get different test questions. They're algorithmically generated, so I don't know what you're going to get. But if just when you get this problem, I'm going to tell you this problem's on there, right? But it doesn't mean A is going to be the right answer, because the numbers that you have up here may create a high value here instead of 28, maybe 35. So the median was still 21. There's more distance from 21 to 35 than there would be from 14 to 21. So that would be a right, well, it calls it a right skew, because the distance from the median to the largest value is higher. So really, for that question, you got to focus on 3 numbers: the biggest number, the smallest number, and the median, and look at just the metric, the directed distance between the two. Yeah, between two sides.
I have questions on the bottom.
Number 12. All right. Yeah, I think this is one of the hardest questions for people.
Now, as far as like I was going through the example, setting it up on the calculator, but is there an easier way to do this in stack crunch?
Absolutely. I think there is. Yeah. And I demonstrated it in StackCrunch. Yeah. So in a recent survey of full-time female workers, 46% said they would rather give up their salary for more personal time. All right. Suppose you select a sample of 100 full-time female workers, complete parts A through C. So what's the probability in the sample fewer than 49% would give up some of their salary? What do you think? I don't know how to do it. Help me out. Okay, I just lied to you. I do know how to do it. I still want you to help me out. I wouldn't pull up StackCrunch yet, but we're getting there. We're headed that way, yeah.
Are we gonna look at the click here to view?
Huh?
Are we gonna look at the click here to view for anything, like the tables?
No, I don't. Stay away from tables. Tables are ugly. Yeah. Because if you use tables, you have to convert these things to z-scores, and to convert percentages, types problems like these to z-scores is kind of complicated.
Well, I know your sample is 100.
Okay.
And then,
Here's what I would do. I would know that I'm going to StackCrunch, and because it says probability, and I have a percentage given, I'm going to model this using the normal distribution. And to have a normal distribution model of problem, what do I need? I need 2 things. I need the mean and the standard deviation. The mean is going to be the percentage that you're given. That's going to be the 0.46. But how do we calculate the standard deviation for these types of problems? Remember the square root of p times 1 minus p over n? All of it is the square root. So guys, grab your calculator and take the square root of 0.46. Now, times, the next thing we do is 1 minus 0.46, but I can do that in my head. That's 0.54. If you can't, that's fine. It's no big deal. It's because I can do something you can't do. There's something you can do I can't do, right? I can do that in my head. I can take the 1 minus 0.46 and I see it's 0.54. If you can't do it, fine. Pick up your calculator and go 1 minus 0.46. No big deal. So anyway, we have 0.46, or I should say the square root of 0.46 see if I can find that online calculator. All right, so what I would do is 0.46 times 0.54, and I would divide that by 100.
What about the square root?
Well, I've got to do that next, yeah. So I'm going to hit enter, and then I'm going to take the square root. Well, actually, I don't need to do it. I can do it this way. 0.46 times 0.54 divided by 100. So that's what I put there. So when I hit equal, the standard deviation is 0.0498. So can you remember that for me?
0.0498. I wrote it down.
All right, 0.0498. So guys, what I need to do now is go to Stack Crunch. And here's a case where I have to go back to the main menu and go to Stack Crunch this way. And this will happen to you because sometimes Stack Crunch isn't accessible to you in the problem. No problem. All right, so I'm going to go to Stat, Calculator, Normal. So my mean is 0.46, right?
Mhm.
What's the standard deviation?
0.0498.
0.0498. And what's the problem tell me that I need or want?
40.
Less than 0.49, right? Was the number 8? Is that right?
I think it's a 12.
Just number 12.
Number 12. So it's changed a little bit, but fewer than 0.49 is what we had at the beginning. So I'm going to go less than 0.49 and hit compute. So guys, the answer would be 0.7265.
It's a lot easier.
Uh,
It's a lot easier than what I figured it would be. A lot
Oh,
better.
really?
My problem is different and I didn't get that answer, but I feel like I could figure it out. I struggled on this for a long time.
So what were your answers in the problem? Well, like what was
So in 47%, 100 workers, and fewer than 51% wanted to give up their salary.
the 51?
Yeah.
So in that, I would so you had 0.47?
Yep.
I would multiply by 0.53.
Yes.
100 workers.
Yep.
So 0.0499.
So I got 0.00499.
Well, somebody did something wrong.
Well, that's probably me, but
So 0.47 times 0.53. Did you take the square root of it?
in the beginning,
Okay.
wondering if that's my problem.
Yeah, I get 0.0499.
Okay, I got it that time.
Okay.
I think it was my calculator.
All right, so we go to Stack Crunch and so 0.0499. And you said fewer than 0.551.
One. Yeah.
So the correct weight is 7.887, depending on how many places you want shit to. The two problems that were most commonly missed on last year's midterm, you guys will get a different midterm, but it'll be close. Same book, same teacher, same everything, right? Were the two questions that y'all have asked about. This one and that question.
Did you happen to go over number 6?
Sure.
I think somebody else asked about that question right before we left.
I'll tell you what, I just did that one. It'll be in the recording.
Oh, okay. I missed that. Okay.
Anybody else have anything else?
I have more questions.
Okay.
Look, I wrote it down. I don't remember what number, but it was right around these. It's like a manufacturing company, and it's like 3% sample of 10. What is the probability that none of the LED? Yeah, that
This one?
7.
I struggle with that until I figured out it was a binomial question.
All right, so a manufacturing company regularly conducts quality control checks at specified periods on product it manufactures. Historically, the failure rate is 12%. Suppose a random sample. What makes this one different than the problem we just did?
Is it the percentage? I don't know.
Well, yeah, this is a percentage too, right? So it's 12%. The other was like 46%. So on this one, okay, it could be. Yeah, it's going to generate different questions. But what makes it different than the previous question? So when you're sitting here or sitting on your exam on Wednesday and you're trying to figure it, this is a binomial problem. The other was modeled by the normal distribution. How can you look at the problem and tell the difference? And that's not an easy answer. The other type problem will tell you there's a sample size. Remember the other problem said they took a sample of 100 people, subjects?
Yeah, we don't
Notice
know.
how this one doesn't.
Mine gave me.
Okay, suppose a random sample of 10, yeah. These will give you a small sample size. Yeah. Because technically you have to get to a certain criteria before you can use a normal distribution. So if you see something like 100 or 64, but if you see something like 7, 8, or 9, or 10, it's a binomial problem. They all meet out there somewhere. The only difference is what's your sample size. If it's large, use the normal distribution, like we did before. If it's small, use the binomial distribution. I'd have that on my cheat sheet. So guys, what do you think we should do here? Use Stack Crunch. And what would I use? Not on these. I would use the binomial. Again, if we have a larger sample like 64, 80, 100, use the normal distribution to approximate. But if we have a small sample like 7, 8, 9, 10, use the binomial distribution. Now, what do I need here? For my problem, what do I need?
The percentage would probably be the P category, so since this is 3%, it would be 0. Well, for me, it would be 0.03.
Exactly. So for me up here, it'd be 0.12, right? But we have 10 LED bulbs, so we'd have 10, right? We want X to be equal to, did it say 0 or 1?
It says none for my part.
Okay. For my part, it says probability that none. So the probability would be 0.2785.
And do we just keep changing the 0 to like a 3? Okay, that's a lot easier.
Yeah, it really is. Isn't it?
Yeah, it is.
They get a little tougher. I mean, if we go to, what does it say, 4 places? What was the answer again?
The answer we had 0.2785.
0.2785. So the next one says, what's the probability that exactly 1? Man, if you get that one, if you get the 0 right, and it asks you probability X equal 1, you should lick your chops. This just changes 0 to a 1.
That's what it happened in the last homework. It was like 95 confidence and it's like 99. I was like, okay, thanks.
Yeah. So 0.3798.
Fewer should mean less than equal.
All right, so the probability of 3 or fewer. Where are we headed with this one, gang? Less than or equal to 3, right? So 0.9761. And what's the probability that 4 or more? Now, one thing that could pop up, I don't think it will, but what if this says, what's the probability that more than 4? What would be the difference in 4 or more?
Would be
That's when you
greater
use
than
the-
or equal to?
Greater than or equal to? or
Yeah,
less than?
greater than equal. Which is when the alligator swallows the X. That's a good way of remembering.
There you go.
Greater
This-
than swallows the X. Less than runs from the X. I know it sounds like elementary stuff, but this kind of thing you can help you remember.
Hey, I still go to please excuse my dear self. 0.0239. You guys, pretty impressive. Y'all have chosen the 3 toughest problems. It tells me that you're normal.
I got like the first half, the last half, but the middle, I'm like, it was probably because the last half's more recent too,
Yeah.
than videos and stuff. And I'm like,
That's a bad thing about this class being 5 hours is not only is there just there's just so much content. You know, you guys have already covered more than I've covered in my 1150 class. Think about it. That's a 3-hour class. It's a 5-hour class. You know, and you've already covered more than we covered. So the pace of things is crazy. Did y'all know this is changing to a 4-hour class beginning in the summer?
Of course. How convenient.
Isn't that crazy? We just got the notification from the Ohio Department of Higher Education.
Is it still required for a business degree too?
Oh, yeah, it is required, yeah.
I do have a question, but it's not about the midterm thing, it's about the assignment 7.
Okay.
Question 5, it's about the last parts. This stuff, this might be covered in the midterm or not, but I'd rather know how it works just in case.
Okay.
It's part C. If you want me to conduct a follow-up study to estimate the population proportion of nonprofits that need to turnover is the biggest employment challenge as their organization to within plus or minus 0.022 with 95% confidence. How many nonprofits?
Okay, what question is it?
Number
5C.
5 on assignment 7.
Okay. Well, it's gonna make me work completely through it. So 83 out of 416.
And I have 422 out of 8.
Yeah, it's gonna be different. Yeah, it regenerates.
And thankfully with the T-STAT calculator, it's easy to construct this confidence level stuff. Part A is obviously
You want me to work completely through this one? So we get, because it's not gonna allow me to go.
we don't have much of a choice here, so.
Very good point. So 83 out of 416. Stat, proportion stat, one sample. It was 43, is that it?
80. Oh God, more than 43. Out of 416, I think you said. 83 out of 416.
83 out of 416.
What problem are you on again?
We are on a problem from assignment 7.
Okay. Which question? 5? Oh, yeah.
It's a good one to do because you might see something like this Wednesday. So 95% was computer. So wants us to go to 3 decimal places. So 0.161, 0.238. Well, guys, when you look at the interval interpretation, you know it has to be C or D, right? So since confidence intervals deal with populations and not samples, I mean, I'm 100% sure that my sample's in that interval because we used the sample to create the interval. So we generalize to a population. So if you wanted to, this is it right here, isn't it?
Yep, that's part C.
All righty, good deal. Now, what I would do remember a formula I gave you?
Yeah.
It said that n is equal to 1. Well, this one should deal with p-hats. We it have something to do with ME and star and P-hat?
We have plus or minus Z star, square root of Z star, and the parentheses is P hat over N.
But there should be something that says. I'm pretty sure this is where I said, I don't want to require a lot of algebra for you, so I worked it out. Worked out the algebra.
This is like the C-fans example, what percentage of C-fans are infected?
It may have been.
I have like I have like N equals 2, 12, and then the P equals 41, that and the P hat, and then X over N, and that equals, that might not be right.
I think I have it written down something similar in the handout about
Yes.
customers reducing the margin of error.
Yes.
I probably have that too, the customer question. N equals, is it this one right here? That one,
That's it.
okay.
No, it's not. That has sigma, right?
Oh,
That's
there's
it,
an N
yeah.
equals up too.
So P hat and 1 minus P hat. And then margin of error over the Z star on the square. Perfect. Yeah, that's for those of you that are home. Can you see it?
Yeah, that looks like the one that I have.
You guys.
That habit trying to write only within the lines.
Okay, no, you got it. It's fine. You got it? Yeah. Okay, all right. All right, guys, so looking at this formula, what am I going to use as P hat? So my P hat is the 83 divided by 416. So I'm going to put 0.1995. I want to go out 4 places because I want to improve my technical accuracy because I'm dealing with small numbers here. Next thing I'm going to do is I'm going to take that and subtract 1. So I'm just going to go minus 1 because I know it's going to be a positive number. So I'm going to do 0.8005.
You said that's positive?
Huh?
You said that's a positive number?
Yeah, it's positive. I mean, if I go 1 minus 0.1995, I get that. I just said when minus 1, I know because of symmetry, it's going to be the positive. Now, next thing I need to do is the numerator, my margin of error. This problem said that it wanted my margin of error to be within 0.04. So I need the margin of error to be 0.04. And guys, what's the Z critical for a 95% confidence interval that's modeled by the normal distribution?
1.96.
1.96. All right, guys, for those of you at home, that's what we would be working with. right?
Like,
There.
So the MC part of formula would be equal to the plus or minus part of problem here.
There really is no plus or minus because we're just wanting the 0.04 in a confidence interval is implied to be plus or minus, right? Because I take my sample estimate and I add 0.04 and I subtract 0.04. So that's what the plus or minus 0.04 is. But I don't need to put the plus or minus in there because it'd be irrelevant anyway once
Yeah. But
once
what
I
I'm saying is
square
that for my problem, for example, I got the plus or minus 0.02. I use that, and I just use 0.02 in place of the MC part of formula, right?
ME.
ME.
Yeah. Yeah, that is an ugly E that I wrote there. All right, so let's try to put this in the calculator without doing anything crazy. So I would probably go 0.1995 times 0.8005 divided by 0.04 divided by 0.96. And I would square that wherever that is. And I get 383. Guys always round up on these problems, so 384. All right. Back to the midterm study guide. Anything else you'd like to see?
I have other things, I think. Can we look at 16?
16? Sure.
Yeah, and it might be really close to what you showed us earlier, but I didn't do it.
Previous part, you said the squared, but, you know, the margin of error times Z star, that's squared. Because I've never seen the Z in it. Let's see, again, these star one, you show me on that paper.
You've never seen the Z star?
I know, I get the Z stars in confidence interval, 95% confidence interval.
Yeah.
1.960.
Yeah.
But I mean, like, do you take the margin of error, apply by that, and square it?
Yes.
Okay.
Square the whole thing. Yeah. I got you. If I were to do this one, this is going to be a pretty cool one because Stack Crunch will do it all.
Yeah.
Just open this in Stack Crunch. So we got our numbers right there. So I would go to stat, T-stat. And first of all, let me make sure that the standard deviation isn't given. Yeah. So since the population standard deviation isn't given, we use T. The one sample with data. I would click that. Make sure 0.95, maybe slip something in. And then just hit compute. So there would be the lower limit, there would be the upper limit. Those are fun.
I just don't want to like not ask a question that might
Oh,
be super
absolutely.
easy, but I was stupid enough for me not to get it right.
Yeah. No. There's no dumb questions.
I'm glad I knew that now.
And I will tell you there is one on there like that.
Yeah, I've had this class before.
Oh.
That's good. Oh, I do have another two question.
Okay.
15. But is there a second part to that?
I don't know. We can do it. Can you remember those numbers?
Or I have it written down.
So we need to go to 1 decimal place, so 23.8, 31.2.
Yes. 23.8 and 31.2.
All right, what do you think?
Um, C. I don't know. Maybe A.
All right, clearly
I
A.
just didn't
So let's talk about why the other ones aren't right. The reason this one is right, and I think a lot can be learned from talking about why that one's right and why the other ones are wrong. We have a 95% confidence interval that the mean miles per gallon, the population mean. That's what a confidence interval does. It estimates the population mean, which is unknown. So that's the reason it's right. Now, why is this one wrong? We can't really talk about all the samples because we got one sample, right? So 95% of all the samples. Secondly, there's a technicality there. It doesn't say whether it's the mean miles per gallon for the sample or the mean miles per gallon for the population. So that's a technicality. Third thing, we have 95% confidence that the mean miles per gallon of this type vehicle for the sample. Don't ever bite on that one. Confidence intervals all contain the sample because that's what the confidence interval is built around. It takes the sample estimate in the middle, it builds margin of error around it, plus and minus, and creates the confidence interval. So I am 100% sure that the sample is in my confidence interval because I used it to create it. Confidence intervals are used to estimate unknown population values. D, 95% of the sample data fall between the limits. We don't use sample data. We use the mean of our sample data. All right, so it would be the first one. All right, good question.
15. 15.
You want to do this one?
No.
All 15?
Well, I got that one right, but yeah, it doesn't matter.
Yeah, these are hard.
Yeah, that was hard.
Yeah, let's do the first one.
Which number is this?
This is number 15. Oh, boy. My graduate students despise these questions. So I know you guys probably will too. So let's do the first one, and then I'm going to turn you guys loose, and you're going to tell me how to do the second one. 1 minus alpha equal 0.95, so we have a 95% confidence interval, you might say. N equals 64. We have an upper tail critical value alpha over 2. So I'm going to write that down. 1 minus alpha equal 0.95, N equals 64. Guys, these are much easier than we make them out to be. Let's go to stat, to calculator, and go to T. All right. When you get these, always go to between. Your degrees of freedom is 1 less than your sample size. So that's 63. The 0.95 is the area that I want between these two values. It's the area under the curve symmetrically between these two values, so I go to 0.95. It compute the negative and the positive. Now, it only wants the right tail probability, the upper probability, so that's just telling you it wants the positive part of it only. So that upper tail right there is defined by the 1.9983. Now, is it going to be right? Better be, right? All right, gang, y'all tell me how to do B.
Stack crunch count T between 63 and
Bless you, Lindsay.
How did you know I sneezed?
Saw you.
I had the sound off. I was like freaked out for a moment. I thought, oh no, my gosh, you can hear me. Not that I've been saying something.
How are we doing this one? The only difference is what?
it's the 90.
0.90 and 0.95, same sample size, right?
Yeah.
So this is super cool.
So that's how you do all those. Do they not like them just because it's repetitive and you have to keep in?
I think the reason students don't like it is they see that T sub alpha divided by 2, and they lose their mind.
But when you use stack crunch, it's not hard.
No, it's not hard at all.
This is why I enjoy this stuff so much.
You actually enjoy this stuff?
Well, I enjoy stack crunch.
Okay. A stack crunch, I'll tell you, I have taught this class with no technology. I mean, I kid you not, I've taught this class over 100 times. It just means I'm old, right? I've taught it over 100 times. I've taught it with graphing calculators, stack crunch, R. Stack crunch is easier than all of them. So degrees of freedom, 63. Again, go between. We want our area between to be 0.90. And you got it. That's all there is to it.
Wow, it's a lot easier than I thought.
I really do think that just the nature of the question, that T alpha divided by 2 and then 1 minus alpha, it's just kind of calculate, kind of clumsy, I think.
Yeah, it doesn't exactly say, hey, this is T-set stuff, and you use that.
I think, okay, what if I rephrase the first question right here? It said, what is the T critical value for a 95% confidence interval where the sample size is 64?
That'd be better.
Yeah, it makes a lot more sense, doesn't it?
Yeah.
Because it doesn't have all the alpha divided by 2s and the subscripts and stuff like that.
I had one to request going over, and it was the second half of it. It was question 10.
Okay. All right, so the diameter of a brand of tennis balls is approximately normally distributed, is that it?
Yeah, I got the first part. It was the second part that got me because I couldn't quite remember how to calculate what it was asking for.
Okay, so clearly the first one's going to be B. So what is the probability that the sample mean is less than 2.57? We have mu equal 2.58. We have sigma is 0.03 from the problem, right? And we want X bar less than 2.57. And we have 11 tennis balls. So this is really just going to be the same as the other. We're going to go to stack crunch, but this time we're going to go to the normal distribution. Guys, the mean is going to be 2.58. Standard deviation will be 0.03 divided by square root of 11. We want that x less than or equal to 2.57. Where a lot of people will mess this problem up is they'll put the standard deviation in at 0.03. And they won't divide by the square root of 11. But anytime you see a problem that right here, if you focus on probability of x bar, when you see probability of x bar, you know you have to take the standard error, not the standard deviation.
And standard error is pretty much square root of n, right?
Yeah, exactly. Now that just said the probability that x is less than 2.57. Then you would just use the 0.05, the 0.03 as a standard deviation. But because it's x bar, you get into sampling distribution, you get into central limit theorem, and you have to divide by the square root.
Is there any way to just add in like square root of 10 on just calculator itself? Because I calculated out 3.162277766.
Yeah, exactly.
So can you say again what, because every question that you guys see is different than the one that I have, because it's 12 tennis balls and it's 2.73. What you put in the standard deviation portion was the standard deviation divided by the square root of n. Is that correct?
Yes.
Okay. And then where did you put in, I wish I could see a little bit better on the screen. Like it says, what is the probability that it's less than 2.71? And so, like I put in 2.71, but it's not calculating. Like there's like a year's, it says whatever I put in the standard deviation is invalid.
So what did you type?
0.04 divided by square root SQRT 12.
So SQRT.
Yes.
Your left parentheses, 12, right parentheses.
It was probably my parentheses.
Yeah.
That'll do it.
Yep. And some people would prefer to do it, it's kind of tomato. Some people prefer to do that, take the square root sigma divided by the square root of n and put it in their calculator first. And then just type the number into the standard deviation. That's fine. I just prefer to do it here because I don't like to.
Yes. For PDF number 10, would it be simply enough to put to write the equal sign, like say 0.70 to get the lower and upper bounds?
So part D of this question?
Yeah.
Okay. So let me get down there. So what was the answer?
0.1345.
Do that again.
0.1345.
Right. So what's the probability the sample mean is between? So 2.5, 2.59.
Oh, I was right.
So 0.8520. Guys, going kind of fast here because all right, this is the one, the probability is 56%. That's going to just be one of the kind of the reverse, right?
Yeah, put it to write the equal sign and bang.
Yeah. 56. So it would be this. So 2.57, 2.59. Yeah, this study guide is set up for you guys to all get different questions. because I wanted to simulate like the exam.
Hey, is number 13 a T-stat question? Because it's asking for like, it's asking for N, so that obviously gives it away as not being a C-stat.
Is it a T-stat? A T interval? Is that your question?
Oh, no. I was asking about number 13.
That's what I'm on, is 13. So is that a T or Z?
Well, it has N, so.
They all have an N.
Example, I know that's more likely to be T.
Is it Z because all we need to find is the mean?
Yes, it's Z because the population standard deviation is given. See that sigma equal 10? That tells it to Z. Or sigma, whatever you've got. Now, if that said S equal 10, or S equal 12, or S equal 8, whatever you got, then it would be a T distribution, it would be a T interval.
I have two more questions.
Okay.
Okay. One was, it's probably a dumb question, maybe. The second part to number 11. I figured out the first, and I just didn't get B.
Okay, so 30 out of 60, so sample proportion. Yeah, that's gonna be easy.
Yeah, that one was just fine.
Oh, standard error. Yeah, this is where you would take the square root of 0.5 times 0.5 over 60. Remember, the standard error of this distribution is the square root of
Okay.
p hat times 1 minus p hat.
Yes.
So if I were going to do that on the calculator, I would do the square root of 0.5 times 0.5 divided by 60.
Okay.
So 0.0645.
So in part, the A part of this same one, you're just doing 16 divided, well, the classified successful divided by the number of people.
Yeah. Where'd I go wrong here?
Zeros.
Oh, no, it says population proportion is 0.75.
Oh,
See, I got sloppy here and didn't read the question. So that would be 0.75. So, guys, first mistake I've ever made, right? Yeah, all right. So it'd be 0.75 times 0.25.
because that's what's left out of the 100.
Yes, divided by 60.
Okay.
So 0.0559. That was awful. I expect you guys to not be impulsive, and look what I did. Didn't even read the question.
Okay, I think I have one last question. It's on number 9, but it was like I figured out A and B, but I didn't get C and D right.
Number 9.
Yeah, I had A and B, but not C and D.
All right, so mu is 55 and sigma is 3. The only one greater than 50. Now, guys, when you look at this problem, you see it's x and not x bar. That means when you use your calculator, you just do standard above. So 55, 3, x greater than So 0.9522. So less than 52, that's kind of redundant. Point 1587. All right, so this is one we want to get to, right?
Yeah.
So for this distribution, 10% of the values are less than what X? So again, what I need to do there is,
Do you put the 10 up in the equals?
yeah. So 0.10 and compute, now make sure that's less than, right? Because
Yeah.
we want less than, so compute. So 51.16. So nearest integers,
And do you put 60 at the end of it too? Is it the same concept, but you do with the between?
yeah, this one, again, you just want 60%, so I would go to stack crunch and do between. I would do 0.60. Between those two values. I cannot stress how much easier that is than the graphing calculator. You have to do normal CDF, and you have to. It's just crazy, the difference. So lucky for you guys. Tyler, any more questions?
I'm working on number 19 right now, but that's a simple one. Still have some other questions, but I'll get back to you once that's taken care of.
Okay.
Is the midterm pretty like I know it's not going to be the exact problems, but pretty close to everything on the study guide?
Very close.
Okay, I don't want anything that I didn't study for to be there.
There's more on the exam, but there's a lot of like open-ended questions. Like
What's open-ended in math?
open-ended would be like to give you like a scenario and you tell me what the sample is in the population. Or maybe is a variable quantitative or categorical.
Oh, okay.
Those types of things.
Okay.
So it's
sorry.
not like calculating
Yeah, wait, that was problem number 1, I think, too, on that. So,
yeah, but there's more of those. Yeah. The sneaky quizzes, those pop up. All those sneaky quizzes that those are questions on here. I mean, all the questions from the midterm come from the demos. You guys look down there and you see not for credit, and you don't do them. That is the dumbest thing. If you're stressed for time, forget everything else and do the demos. Because the demos are where I bring the content to my stat lab. If you know the content but you can't work my stat lab, then you can't do the problems. If you can work my stat lab but don't understand the content, you can't work the problems. The demos are where we merge the two. Those are the most important video. That's the most important video I put up. But students look at that, they see not for credit, and they're like, well, I'm going to do this. In moving forward, if you're really stressed for time, do that above everything else.
Okay. I'd like to go through number 8. I got A done, but for some reason B is being a little problematic.
Okay, so number 8.
Mhm.
All right, so Z between negative 1.53 and 1.82. I'm sure these aren't your numbers, but you can watch and generalize.
Which one did you go to under calculator?
Normal calculator. All right, so 0.9026. Yeah, this isn't a between. You have to do two different problems here and add the.
Yeah, add the two together. That's
Yeah.
not- that's it. Doing that. it gives
So
a little-
less than 1.53, so I have less than 1.53 and greater than 1.82. And keep in mind, you want to go to 4 decimal places, so we want to take our answers to 5, so we get technical accuracy. So So 0.06301. Greater than 1.82. 0.03438. So 0.0974. I say we're off just a little bit. Probably just didn't missed about maybe a 10,000.
Yeah, because mine look for a Z-score of 1.57. Give me 0.582. And
We'll go out 5 places. So because you're right, you got to put your answer in 4 places. So you need to go out further than that. So you get So you get the don't get a rounding issue. So what about part C? What is the value of Z if only 5.5% are larger?
given that
Only 5.5% are larger. That. Gang, what do you think? Are we prepared?
Yeah, I still didn't get number 12, but I can go back and watch the recording. I'm really frustrated because I've tried it about like 10 times. I'm ready to just chuck my calculator out the window.
If you do, take a video of it.
Okay. Probably doesn't help that I'm not feeling well, so
Yeah.
I'm not thinking well. I can go back.
Are you talking about 12A?
Yes.
Let's work it real fast. Tell me the numbers you had.
So it says in a recent survey of full-time female workers, 49% said they'd rather give up some of their salary for personal time. Sample size is 100. And they want to know what the probability is in that sample that fewer than 53% would give up their salary for more personal time.
All right, let's do it. First thing we want to do is go to the calculator and find the standard error. So I would go to square root of 0.49 minus 0.51, the one I'm showing up here, divided by 100.
So, what's it for me? So would it be 0.43 times 0.49 times 100?
If it's 0.43, it'd be 0.57, because it's p hat and then 1 minus p hat. So Lindsay, the standard deviation would be 0.04. Let's just call it 999.
Okay.
All right, so now we'll go to Stack Crunch. Let's go to Stack Calculator Normal.
So what is my mean?
It's going to be 0.49.
Okay.
Standard deviation will be what we just calculated, 0.04999.
And then 0.53.
Less than 0.53. So I get 0.7882.
I think I was putting my 0.53 in the wrong place.
Uh-oh.
Yeah, I think we want to 0.57 times 0.49, right?
No.
Okay. That helps.
Let me tell you the problem. What's the first percentage you get?
49% is it, 43% is in the first part.
Okay, so it'd be 0.43 times 0.57 divided by 1,000, or 100, I'm sorry. All under the square root.
Times 0.51 divided by 1.
No, 0.43 times 0.57.
My actual A problem is actually 49%.
But you're not there yet. Don't put that in until you get to the Stack Crunch. First thing you do is calculate the standard error. And you only use the percentage that's given in the problem. Then when you go to Stack Crunch to calculate the probability with the normal calculator, then you use the problem that's the number that's in the part A. Well, guys, I'm ready to go home. I'm tired.
I'll just look over the video.
I did want to ask really quick on the exam, are there going to be multiple attempts for one problem, or is it only one attempt per problem?
Yeah. But the difference is I'll go through and hand grade and assign partial credit because, you know, it's pretty clear to me from the answers that you give whether you know what you're doing or not. And if you're off maybe 1,000 or 10, I don't think it's fair for you to miss the whole problem. So that's the correction there. If you do just get 1 of 10.
Okay.
And part of that is to kind of preserve the 2-hour timeline. Part of it, that's the way that my stat list sets up the test. So.
Understandable.
Thanks for coming. Hope y'all do great.
Thank you for having it.
This makes me miss face-to-face classes.
Video will be up on the platform, right?
Video. Bye, Lindsay.
Bye, Doug.
Bye, Robert.
Later.
You guys are the only two still hanging with me, aren't you?